Hello, it's Keith here, and this is lesson 20 of the platform-specific series of my Z80 programming tutorials. Now today, hopefully the video is going to be a bit better quality because I'm going to be using OBS Studio for my recording instead of Cam Studio. So in theory the video should be better quality, but in practice I'll probably mess it all up and have to do it twice. Anyway, let's see how things go. Last week we were looking at the Enterprise and how to make sounds on that system. It's another obscure system today. We're going to be looking at the Sam Coupe. So how does the Sam Coupe compare to our other systems? Well, very favourably in fact. The Sam Coupe has 6 tone channels, 2 noise generators, it's capable of envelopes, it's very, very powerful. So we're going to have no problems with our sound, especially being as we're only creating ChibiSound, which if you've missed the other weeks, just creates simple beeps and noise sound effects for SFX within our games, and it was used in the Grimes Z80 project. But as I say, in general, this is going to be just showing you how the registers within the Sam Coupe sound chip work, so that if you're looking to do something more advanced, you'll know where to start. So the Sam Coupe sound chip in theory has 32 registers, though not all of them do anything. So let's have a look. So here they are. So you can see that there's a bank set to defining the volume, and we can define the volume of the left and right channel independently, so we've got a lot of flexibility there. Then we've got tone generators, which is of course just a sort of beeping note. Can create a square wave with those. We also have octaves. Now you'll notice quite strangely the tone is a single byte here, but then the octave uses 3 bits of a nibble in here, and so the channels are kind of joined together into 3 octave registers to make up the 6 tone channels. So that gives us the ability for fine tuning and for generally changing the octave here. We then have our mixer, as it would be called in the AY sound chip, which is where we turn the channels on and off, and 0 is off. Now we have a noise enable. We can turn the noise on to any one of the 6 channels. Even though there's only 2 noise generators, they can output all 6 channels. So again, some flexibility there. We then have the ability to define how the noise is created. And we have 4 options. We have 3 general frequencies of noise, which aren't that useful. However, we can link one of our tone frequencies to the noise generator to create much more flexibility. And that's what ChibiSound is going to do, because we want a wide range of noise. So this of course loses us 1 tone channel, because presumably we'll want that the tone of that channel muted, but because we do have 6 tone channels, we're not really going to miss one here or there. So we can use channel 0 and channel 3 for our 2 noise generators, and then we can use the remaining 4 for our actual tones. Now there is also 2 envelope generators, and again these can take their frequency definitions from one of the tone channels, and we'll have a look at that later. And then finally the last register is just going to turn on the sound chip, and if we forget to do that we're going to get no sound. So that's what we need. So let's start looking at our actual code. Now if you saw last few weeks, we're going to be doing the same thing. So we've got some frequency analyzers here just for a bit of visual fun, so we can see the sound on the screen as we hear it. And I've got a very simple example here, which is setting various values into the sound chip, and we're going to see how those affect the sound we've got. So first we're going to have a play with the general tones, and then we're going to play with noise, and then we're going to play with the envelopes a little bit. I don't tend to cover envelopes too much because they're very complex, but in all cases the source code I'm going to show you today is available for download from my website. So really, if you want to get into this, I'd suggest you download that source code or write your own and play with the options within it, change the values, just see what sound good, and then just use those rather than, I mean, you can work it out sort of mathematically and figure out what envelopes you want, but it's often a lot more fun and a lot simpler for people who aren't so familiar with music and things to be able to do this, because I don't really understand music and sound effects that well. So for me, it's often easier just to play around with the values until I get a sound that sounds roughly what I wanted, and that helps me learn what those values do as well. And that's what we're going to be doing today. So let's just compile this. You'll see it's very graphically boring, but you can hear now there's quite a nice sort of fairly high-pitched tone there. Okay, so what we're going to do now is we're going to play with some of our options here. Now, I said before we've got an octave here, so let's try changing that. So it's these 3 bits that affect channel 0, which is the one we're using here. So what we're going to do is we're going to change our number down 1. Now all of our values here, you can see we're using A and D, and A is selecting a register number and D is selecting the new register value, and we're using this set sound register command in every case here. Well, what's that set sound register command? Very simple. Now, as I've mentioned before, on the Sam Coupe, the out ports use B and C simultaneously. It's a 16-bit address, so we have to use B and C, And so the register select port, which we have to use first, is 511. So we just send our new register number to 511, and then we set the new value for that register to port 255. That's all we have to do to set a register. It's very simple, very, very nice to work with. So here you can see we're setting register 1C, and we're setting bit 1 of that. I'll just move these along so it's clearer. So bit 0 is the enable bit, and we're just doing that to turn the sound on. And then we're setting both the left and right nibble to full volume here. And then we're setting a tone, and this is just a sort of general value here. It doesn't really matter. We can play with that later and see how that affects things. And then we're setting our octave to number 2 here. And we're turning on channel 0 with this bit 1 here. And of course, if you look at our table before, you'll see we can use different registers if we want to use one of the different tone channels. But the principle will of course be the same. So we've changed our octave here, so let's run this again and see what happens now. So now you can see the tone is much louder, and I said C, and that was a bit of a Freudian slip there, because you can see here that the tone is being visually represented, and the wider the waveform is here, the lower pitch the tone. The taller it is, if you don't know, will be louder. So if I make it half the volume, it will be much shorter. And we'll just try that now. So you can hopefully see it's a lot shorter now, and the volume has gone down. Just undo that. So let's have a play with this. As I said, this is the sort of fine tuning. So we want to make a fairly large change here, because if I just decrease it by 1, you won't hear any difference at all. So you can hear it's gone down a little bit there. And if we set all of these to 1, we should get a very high-pitched tone, which will probably make any dogs go crazy. So there we go. We can play around and maybe create a hearing test or something with that. So that's how we make general tones. We can turn all the left channels off, and so the tone will sound to the right. We can do our fine tuning and our major tones, and of course we can turn more channels on if we want them. So that's how to just make a very basic tone. So let's turn those off. Just rem all of those out there. And let's turn these on now. Now I've made a stupid mistake there. I've actually turned off the sound enable command. That won't go very well, so we'll turn that back on. And let's turn on noise enable, which is this one here. And you can see we're turning on the noise to channel 3. We don't have to use channel 3, but channel 3 has some special effects that we can use with our noise. And then we need to set the noise configuration. So these are the 2 noise bits for channel 1, which is bound to channel 3 if we're going to use channels. We do have a need to turn the volume for the channel on. So we're going to start with option 00, and we're going to turn the volume up to the maximum here. And if you look at the documentation here, 00 is 31 kilohertz. So a very high pitched noise there. And then if we change this to 01, and maybe you can tell it is slightly lower frequency now, but not much difference. And then 10, and a more kind of muffled noise there. Now those aren't particularly useful. You're probably thinking, well, yeah, I wanted to create some explosion effects and things, and those are just kind of distuned television sounds, so they're not very useful to me. Well, what can I do about this? Well, this is where you pull in your other tone channel, and this is why you can see tone channel 3 mentioned here. Because if I set these to 1, you'll see this now binds in to channel 0 for frequency generator 0, and channel 3 for frequency generator 1. And I think at this point it's time for me to show you the details of how the sound chip works, because it's quite complicated if you really want to know the details of how the tone channels affect the other effects. So let's have a look. And what you need to do is you want to get the PDF. It's linked on my website. And here it is. So this is the sound chip that does the Sam Coupe sound, and you can see we've got a nice description here. We've got lots of details, and this is the one we want to see. We'll have a look at that in just a moment, but first we'll just go down to see the rest of the contents. So a lot of this is very technical, and it's quite confusing. It took me a long time to get my head around it, and hopefully you can use my website, because the documentation on there should be simpler. for you to get the job done. But if you want to know all the details, you probably do want to go here, or maybe I've made a mistake. This is the thing you need to see for the envelopes. These are the shapes of the envelopes that will apply to the sound. If you don't know, an envelope in this case will affect the volume of the sound over time. So if you want the sound to come in and go out, or you want to get louder and disappear, or vice versa, you see these are your envelopes that can do that. But the one you really want to see if you want to understand how the noise effects is affected by the tone channels is this one, and you can see it's the wrong way around, but never mind, I've done something about that. So here we've got this, so you can see this is how the actual sound comes in and how everything works. Now you don't need to worry about this, and you don't need to worry about this, and you don't really need to worry about this too much either. The important thing is this bit here. So here are our frequency generators 0, 1, 2, 3, 4 and 5. Here's our noise generator 0 and 1, and here's our envelope controllers 0 and 1. And you can see that noise generator 1 is linked to frequency generator 3 here, but then goes out to all three of these channels here. And envelope generator 1 here is linked to frequency generator 4 and only goes through frequency generator 5. So you can see that frequency generator 3 is can be related to the noise, 4 can be related to the envelope, and 5 is used by the envelope as the sound source. So, and the same kind of a thing for these three up here. So you can see that it's quite complex how the sound passes through them, and if you want to do music and make the real best of this sound chip, you would want to have a good understanding of this and decide how to use your channels effectively. But in today's case, we're just going to be doing very simple stuff for you, so we don't really need to worry too much. So there we go. So that's the theory. So now we've got the noise generator bound to sound channel 3. So what we want to do is we want to set a tone for that channel. So we need to enable an octave here. So this is our octave command here, and we're setting these 3 bits here. So our octave is going to be quite high. And let's have a listen to that. Okay, so not actually that high. Maybe we can make it a bit higher. And there you can go. You can hear it's higher pitched now. But maybe what we actually want is some lower sounds. So if I turn these 2 to 0. Now we've got a kind of a rumble. This is a bit more interesting maybe for our game programming. So we'll change it to 1, 0. There we go. So now we've got a kind of a good sort of shaking effect, or maybe an explosion, or something being destroyed. Nice exciting sound there. And you can play with all of these tone effects to get the real sound you want. And of course you can change the tone over time to make a sound that is altered as time passes, which will give more realistic effects maybe, and maybe give a bit more exciting effect to your games and things. So that's how we can play with the noise pitch. So it's pretty easy, just rather confusing with that we do have to configure our tone channel. Even though we don't want to make a tone, we actually just want to hear it make a rumbling sound. And you can see here, although we've got the noise channel enabled here, we don't have any tone channels enabled, which is why you can't hear the tone, you can only hear the noise. So that's important to follow. So that's the theory of the noise channels. Pretty easy there, really. So now let's have a look at the confusing world of envelopes. So as I've said, an envelope is how we can change sound over time. So how do envelopes work on the Sam Coupe? Well, in the same way as with the noise channel, we can link one of our tone channels to the speed, and we can link another of our tone channels to the sound. So in this case, we're going to use tone channel 2 for the tone, and tone channel 1 for the speed of the envelope. Now when we come to define our envelope, we use these 4 bits here, which will select an envelope number. We have a rate bit which will speed things up, and we have the enable bit here, which we need to set to 1 if we're going to use an envelope. When we want to check what envelopes to use, you need to look at the manual here, and so we're going to use 1110, which is this kind of sawtooth shape here. And so let's have a listen to that. So you can hear it's getting kind of louder and then dropping out, which is this one here. Now let's set this bit to 1, which will mirror it. And you can hear now that this is mirrored between the channels. It's quite an interesting effect there. So let's just turn that off. And then what we can do now is we can play with that sound. Let's just try a different one. Let's use this one. So we've got a fading in and fading out effect there, a little bit more calm. So if we set these two bits to 1, we're setting the octave of tone channel 1, and tone channel 1 isn't making the sound, it's setting the speed of the envelope. So now you can hear it's much faster, and it's more like a constant tone. And so if we just speed it up again, and now it does sound like a constant tone. So let's just try slowing it down a little. There we go, we've got a very fast wave envelope there, and we can fine tune the envelope again with these. And so there you can see we've got quite a lot of flexibility, and you can see the waveform is changing over time there, which is what the envelope is doing. So we've got a variety of options there, and we can use this rate option here, which will increase things. And now it's much faster. So that's the basics of how to use the envelope. Again, I'd suggest if you want to play with it and try all the different envelopes that are available to you, you download the example source code and have a go, because you can do this yourself. Now, that's the basics of how we're going to control the sound, but what are we actually going to do with it? Well, in the same way as last week, we're going to recreate ChibiSound, which is my sound driver, on every one of the systems these tutorials are going to cover. Now, what's ChibiSound? Well, it takes a single byte value from 0 to 255, and it creates a pitch that is either loud, quiet, or loud and distorted, or quiet and distorted. So we can make various bleeps and noise effects for our games, and this was used in Grime Z80. So let's just hear it in action. So you can see this is the byte value being passed to ChibiSound, and you can hear as it gets lower, the pitch is getting higher. And now when it reaches 40, which is 64 in decimal, it starts again, but it's slightly quieter. So we've got 2 volume options and a range of 64 pitches, and 0 will turn the sound off. And you can hear now we're into the distorted sounds, because when the top bit is 1, the sounds are distorted. When the next bit is 1, bit 6, then it's loud, and the remaining bits are all used for the tone. So there we go. So let's have a look at how ChibiSound actually works on the Sam Coupe. So here's ChibiSound, and so our value is coming in A, and we back it up into H because we need a backup for when we're applying various tricks. So first we want to see if the sound is off, and if it is, then we come down to here and we just turn the noise and the tone channels off, and that will do the job. You can see we're using our set sound register command in exactly the same way as the last example. So really now we're just filtering this input into the correct locations. Now when it comes to setting the volume, what we're doing here is we're checking if the 6th bit is set, and if it is, then we're using this high volume setting, and if it's not, we're using this low volume one. So that's how we're defining our low volume here. And then either way we carry on to here, and at this point we're saving this new value for our volume into D. We then select sound register 0 because it's 0 making our tones, and we set the volume there. Next we want to turn the sound tone channel 0 on, and we do that here. Now we will need to get the low 4 bits of our tone, and we need to shift them along to the right, and then we fill in the remaining bits with 1 so that the tone bits will be loaded into here. And then we set this to the low tone register. We take the remaining unused 2 bits and we use these to set the octave, and this gives us a wide variety of tones, so that's what we want. Now we want to check the top bit. If the top bit is 0, then we're actually already done, but if it's not 0, then we want to turn on our noise channel. So we enable our noise channel here. We define the noise channel to use the tone 0 for its noise source, and we turn the noise off. And because we've already set the tone here, we don't need to do any more at this point, and we just return. And that's all it takes to get the ChibiSound driver working on the Sam Coupe. And as I've explained before, we're going to continue making this ChibiSound not just on the Z80 systems, but we're even going to go on to the 6502 and the 68000 systems in the future. So ChibiSound, although very, very crude, is going to give us a very quick and easy way of getting just some basic sound effects to our game really quickly. And as I've said before, even if this is completely inadequate for your needs, it's a great way to look at different systems and see quickly how to get your sound working so that you can build on it and make better things. So that's today's lesson done. I hope you've enjoyed it. Next week we're going to continue with ChibiSound and with our sound testing, and we're going to do the Game Boy and the Game Boy Color, which of course have the same sound chip anyway. I hope you've enjoyed today's lesson. Thanks for watching. Please like and subscribe to the channel if you have. I hope you'll join me next week. Thanks for watching and goodbye.